Yeah, good morning one and all. So in the first unit we have discussed about differential amplifiers. So types of differential amplifiers, block diagram of operational amplifier, the characteristics of operational amplifier, the current mirror, level translator. Okay. So these topics we have discussed in the first unit. In the second unit we are having op-amp with negative feedback and frequency response. This is op-amp with negative feedback and frequency response. See here. So what are the different types of feedback configurations? So all of you know about this voltage series feedback, voltage shunt feedback, right? And differential amplifiers and properties of practical op-amp and the frequency response of op-amp. So compensating networks. So in the compensating networks, now we have dominant pole and pole zero concepts. Non-compensated op-amp, high frequency op-amp equivalent circuit, open loop gain versus frequency, closed loop frequency response, and these are the contents in the second unit. So here all of you know about feedback. What is feedback? See here. First of all, we will see what is the difference between open loop op-amp and closed loop op-amp. So open loop op-amp, here in the case of amplifiers, the term open loop indicates that no connection exists between input and output terminals. Okay, so that is called open loop op-amp. So in the open loop op-amp, there is no connection between input and output terminals. That means there is no feedback. Okay, there is no feedback from output side to input side. That is in the open loop operational amplifier. So here we don't have any connection from output side to input side. So the output signal is not fed back in any form as part of the input signal. Okay. So if we see the closed loop, here the gain of the op-amp can be controlled if feedback is introduced in the circuit. If we make a connection from output to input, so through that the gain of the op-amp can be controlled. So here an output signal is fed back to input either directly or through some other network. So in the closed loop amplifier, the output signal is fed back to the input, so either directly or through any other networks. Fed back in opposite or out of phase by 180 degrees with respect to the input signal. That feedback is called negative feedback. Okay. So see the difference between open loop and closed loop. So in the open loop, there is no connection from output side to input side, right? So the input does not know what is happening in the output side. In open loop, the input does not know what is happening in the output side, that is in the open loop. But in the closed loop, the part of output signal is applied to input side. The part of output signal is applied to input side. So in the closed loop, it can be controlled. So the gain of the op-amp can be controlled if feedback is introduced in the circuit, right? So here the input knows what is happening in the output side. The input knows what is happening in the output side. So that means the part of output signal is applied to input side, right? So that is called feedback. In feedbacks there are two types. So one is positive feedback and another one is negative feedback. If the output signal is fed back to input side in phase, that feedback is called positive feedback. If the output signal is fed back to input side with 180 degrees phase shift, that is called negative feedback. Okay, so we have two types of feedbacks, positive feedback and negative feedback. So in the negative feedback, the overall input is going to decrease. In the positive feedback, the overall input is going to increase. Okay, so the part of output signal is subtracted with the input signal. That's why the overall input signal is going to decrease. That is in the negative feedback. If you see the advantage of negative feedback, so due to negative feedback, the gain decreases, the distortion decreases, and the input impedance increases, and the output impedance decreases. So if you see the advantage, these are the characteristics. These are the characteristics of the negative feedback. If you see the advantage, the distortion is going to decrease, the input impedance increases and the output impedance decreases, the bandwidth increases. Okay, so if you see the drawbacks of the negative feedback, here the gain decreases. That is the drawback of the negative feedback. Okay, in negative feedback we are having different types of negative feedback amplifiers. So all of you know about this voltage series, voltage shunt, current series and current shunt feedback. Here this negative feedback is applied to the operational amplifier. The negative feedback is applied to the operational amplifier. So here a closed loop amplifier can be represented by two blocks, one for an op amp and other for a feedback circuit. So here there are two blocks, right? So one is for operational amplifier, it is for the basic amplifier, and the other block is for feedback network, feedback circuit. So there are different types of negative feedback amplifiers. You see here it is a voltage series negative feedback. Voltage series negative feedback. This one is voltage shunt negative feedback. It is a current series negative feedback. It is a current shunt negative feedback. Right? So in voltage series, the part of output voltage. So the type of sampling signal is voltage. The type of sampling signal is voltage, right? So it is applied to the input side in series mixing. It is applied to input side in series mixing. In voltage shunt, the part of output signal, so that is here the type of sampling is voltage, that is applied to input side with shunt mixing. Okay, so in current series, the sampling signal, that is the output signal, is applied to input side in series mixing. In current shunt, so output current is applied to input side with the shunt mixing. Okay, so these are the different types of operational amplifiers with feedback. Operational amplifiers with feedback. So voltage series, voltage shunt, current series and current shunt. So in this, it is a basic amplifier. This block represents a basic amplifier. So this block represents a feedback circuit. Here Vf is a feedback voltage. So this Vin. So Vin or Vs. Okay, Vin or Vs. It is the input for the complete circuit. The input for the complete circuit, that is op-amp with feedback. Here Vd is the input for the basic amplifier. See the difference between these two inputs. So Vd and Vs are Vin. So Vd is the input for the basic amplifier and Vin is the input for the complete circuit, that is with feedback. Okay. Here the gain without feedback is, we can write V0 by Vd. The gain without feedback is V0 by Vd. The gain with feedback is V0 by Vin. The gain with feedback is V0 by Vin. The gain without feedback is V0 by Vd. So beta is a feedback factor. Here Vf is the feedback voltage. Vf is the feedback voltage. Okay. So if you see the voltage series feedback amplifier, so it is also called as non-inverting amplifier. It is also called as non-inverting amplifier. So we have different types: inverting amplifier, non-inverting amplifier, right? So it is a voltage series or non-inverting amplifier. Here the output voltage is V0, the input voltage is Vs, this difference voltage is Vd. Okay. Here the feedback output voltage, feedback voltage is Vf, right? See here, it is the equivalent circuit for voltage series. This is the equivalent circuit for voltage series. Here we are having the feedback, that is the output is connected to the input side through RF, feedback resistor. See here, the part of output is connected to input side. The part of output is connected to input side through feedback resistor RF. So why it is called non-inverting amplifier? Here the input signal is applied to non-inverting terminal. The input signal is applied to non-inverting terminal. So this is called non-inverting amplifier. If the input signal is applied to inverting terminal, so it represents the inverting terminal. Minus, it indicates the inverting terminal. The plus sign indicates the non-inverting terminal. So in the non-inverting amplifier, the input is applied to non-inverting terminal, right? So this feedback signal is applied to inverting terminal. The feedback signal is applied to inverting terminal and the input signal is applied to non-inverting terminal. Okay. So here these two resistors R1, RF, it forms a voltage divider network. It forms a voltage divider network. The voltage gain with feedback. The gain with feedback and without feedback. First see, the gain without feedback means the output voltage is V0 and the input voltage is Vd. The gain, that is the gain without feedback, right? So V0 by Vd. The gain with feedback is V0 by Vs. So the gain with feedback is V0 by Vs and the gain without feedback is V0 by Vd. Okay. Here the feedback voltage Vf equal to beta V0. So the feedback voltage, if you see here, the feedback voltage Vf equal to, it is a feedback network beta. To multiply with this V0, then Vf becomes beta V0. So Vf equal to beta V0. So there is a gain without feedback, gain with feedback, and the feedback voltage Vf. Okay. Here we have to calculate the gain, input impedance, output impedance, okay, and bandwidth. See here, how to calculate beta, that is the feedback factor. So from this circuit, the beta equal to R1 by R1 plus RF. So R1 by R1 plus RF. So the voltage across R1 is the feedback voltage. The voltage across here, the voltage across R1 is the feedback voltage. So how to calculate this feedback voltage? That means the voltage across R1. So this resistance. So using voltage divider rule, so it is R1 by total resistance R1 plus RF into V0. So here it is connected to V0, right? So it is connected to V0. The voltage across R1, that is the feedback voltage. So Vf equal to R1 by R1 plus RF into V0. That is the feedback voltage Vf. So R1 by R1 plus RF into V0. So we know that the gain without feedback A equal to V0 by Vd. Right? So from this, the gain without feedback A equal to, so V0 by Vd, and Vd equal to, so difference voltage. Here the two inputs are applying to this operational amplifier. The two inputs are applied to the operational amplifier. So V1 and V2, right? V1 and V2. So this we can write Vd equal to V1 minus V2. Vd equal to V1 minus V2. So V0 equal to, we can write V0 equal to A into, in place of Vd, you can write V1 minus V2. So here V1 equal to Vs, right? So from this circuit, we can write V1. So that is the voltage applied to the non-inverting terminal. Voltage applied to the non-inverting terminal, that is Vs, right? So we can write V1 equal to Vs. One second. Okay. So V1 equal to Vs. So V0 equal to A into Vs minus Vf. So this we can write V0 equal to AVs minus AVF. Okay. So substitute Vf value in this equation. Substitute feedback voltage Vf. So AVs minus A into R1 V0 by R1 plus RF. Okay. So substitute feedback voltage, so in this equation, then you will get, so AVS equal to V0 into 1 plus AR1 by R1 plus RF. Okay. So Vs, bring this side, so then V0 by Vs equal to A by 1 plus AR1 by R1 plus RF. So take R1 plus RF LCM. So V0 by Vs equal to A into R1 plus RF by R1 plus RF plus AR1. So here AR1 is greater than R1 plus RF because A is the gain, right? So gain is very high. So this value is greater than R1 plus RF, right? So we can neglect this one. Then we can write AF equal to V0 by Vs equal to A into R1 plus RF by AR1. Okay. So then what is the gain with feedback? So this we can write 1 plus RF by R1. Okay. So A cancel. So this we can write 1 plus RF by R1. So that is the gain with feedback. So gain with feedback equal to 1 plus RF by R1. In the voltage series negative feedback amplifier with op amp. The voltage series negative feedback amplifier. In the voltage series or non-inverting amplifier, the gain with feedback is 1 plus RF by R1. So next, Next parameter is input impedance. Input impedance. See here, it is the equivalent circuit. So input side are having this V in and I in. So input voltage and input current. So VD is the input voltage for the basic amplifier, and V in is the input voltage for the total circuit, right? RF is the feedback resistor. So here AOL VD, this one is the AOL VD, this is the voltage generator. This is input resistance RI. So here the input resistance with feedback RIF equal to V in by I in. The input resistance with feedback RIF equal to V in by I in, right? So input voltage by input current. Input voltage by input current. And the input resistance without feedback RI equal to VD by I in. VD by I in, right? So here VD is the input voltage for the basic amplifier, that means without feedback. So we can write input resistance without feedback RI equal to VD by V in. Sorry, VD by I in, right? VD by I in. The input resistance with feedback RIF equal to V in by I in. V in by I in. Okay. So for the negative feedback, we know that gain with feedback, that is V0 by V in equal to A by 1 plus A beta. Okay. So for the negative feedback, the gain is A by 1 plus A beta. So here input resistance without feedback is VD by I in, and the input resistance with feedback is V in by I in. So here RIF equal to, so how to write? RIF equal to this one. RIF equal to V in by I in, right? So V in by I in. So what is I in? So this we can write VD by RI. Here VD equal to V0 by A. So we know that A equal to V0 by VD. And substitute VD in the above equation. Then RIF equal to V in by, so VD equal to V0 by A. So from this equation, VD equal to V0 by A. So in place of VD, so substitute V0 by A. Then we will get RIF equal to V in by V0 by A by RI. Okay. So substitute V0 in the RIF equation, then you will get this one. So RIF equal to RI into 1 plus A beta. RIF equal to RI into 1 plus A beta. So that means the input resistance with feedback is increases by 1 plus A beta times. The input resistance with feedback is increases by 1 plus A beta times. Okay. So that is the input resistance with feedback. See here. So RIF equal to V in by I in, and RI equal to VD by I in. Okay. So from this we will get RIF equal to V in by VD by RI. So and VD equal to V0 by A. So substitute this VD and substitute V0 in RIF equation. Then finally we will get RIF equal to RI into 1 plus A beta. Okay. So next, output impedance. So how to calculate the output impedance? how to calculate the output impedance. So while calculating the output impedance, the two conditions must satisfy. The first one is input voltage. This input voltage must be 0. So input is short circuited. Input is short circuited. So here Vin equal to 0. And connect one voltage source at the output terminals. Okay. So these two conditions must satisfy while calculating the output impedance. Connect one voltage source at the output terminals. See here, this one is. Connect one voltage source at the output terminals and input must be short circuited. So then Vin equal to 0. Okay. The remaining circuit is same. See here, the output impedance with feedback, that is RYF equal to V0 by I0. V0 by I0. The output voltage by output current. The output voltage by output current. The output impedance with feedback V0 by I0. So there is the output voltage by output current. So next apply KCL at this node. Apply KCL at node N. Here we are having two currents. Okay, I0, IA. Okay. See here. Here I0 equal to IA plus IB. Here I0 is divided into two currents. First one is IA and IB. So here I0 is divided into two currents, IA and IB. This one is IB. Okay. So IB is flowing through RF and IA is flowing through R0. So RF value is very high. RF value is high, so IB can be neglected. So we can write I0 equal to IA. So we can write I0 equal to IA. Okay. So IB is neglected because RF is large. So the current flowing through RF is neglected. This small, right? So then apply KVL to output section. Apply KVL to output section. Then you will get V0 minus I0 R0 minus AVD equal to 0. So if you apply KVL to output section, then V0 minus I0 R0 minus AVD equal to 0. See here, V0, this one, minus I0 R0. So I0 is flowing through R0 and this voltage source, AOL VD, right? If you apply KVL to output section, then you will get V0 minus I0 R0 minus AVD equal to 0. So from this I0 equal to V0 minus AVD by R0. So I0 equal to V0 minus AVD by R0. And we know that VD equal to V1 minus V2. VD equal to V1 minus V2. Here, what is the V1 value? So it is 0, right? So V1 equal to 0. Then substitute V1 equal to 0 in the VD equation. Then we will get VD equal to minus VF. Okay. So here the difference voltage VD equal to minus VF. So substitute this VD in this equation 1, that is I0 equal to V0 minus AVD by R0. Substitute VD equal to minus VF. VD equal to minus VF, right? And we know that VF equal to beta V0. Okay. So substitute this minus beta V0. Then we'll get I0 equal to V0 plus A beta V0 by R0. So from this V0 by I0, that is output resistance with feedback, V0 by I0 equal to R0 by 1 plus A beta. R0 by 1 plus A beta. Here the output impedance decreases by 1 plus A beta times. The output impedance decreases by 1 plus A beta times. the output impedance decreases by 1 plus A beta times. Next one is output offset voltage with feedback. Output offset voltage with feedback, it becomes, so it decreases by 1 plus A beta times. The offset voltage also decreases by 1 plus A beta times. So the output offset voltage decreases by 1 plus A beta times. So this we can write output offset voltage without feedback by 1 plus A beta. Right? Here also in the output impedance with feedback, it is the output resistance without feedback by 1 plus A beta. Right? So the output offset voltage also decreases by 1 plus A beta times, and the bandwidth increases by 1 plus A beta times, and the bandwidth increases by 1 plus A beta times. Okay? So this is about voltage series or non-inverting amplifier. Okay? Voltage series or non-inverting amplifier. So in the non-inverting amplifier, the non-inverting terminal, that is the input voltage, is applied to non-inverting terminal, right? In the non-inverting amplifier or voltage series amplifier, the gain with feedback equal to 1 plus RF by R1. The gain with feedback is 1 plus RF by R1. The input impedance with feedback RIF equal to RI into 1 plus A beta. So it increases by 1 plus A beta times. And the output impedance with feedback is R0 by 1 plus A beta. R0 by 1 plus A beta. The output impedance decreases by 1 plus A beta. And the bandwidth increases by 1 plus A beta. And the output offset voltage and the distortion decreases by 1 plus A beta times. Okay? So this is about voltage series of non-inverting amplifier. With this I am going to stop the presentation. Do you have any doubts?